Today's notes are on the combined gas law. So what is the combined gas law? Well, combined gas law is when we have three gas variables changing. Unfortunately, Boyle's, Charles, and Gay-Lussac's laws do not individually work, so therefore we need to use a new equation. We take all three of those gas laws and combine them to come up with P1 V1 over T1 equals P2 V2 over T2. And P1 is starting pressure, or initial pressure. V1 is initial volume. T1 is initial temperature. And P2 is ending pressure. V2 is ending volume. And T2 is ending temperature. And just like before, the temperatures must be in Kelvin. And the number of moles is the only constant variable. So when the only thing that's not changing is our moles is when we use the combined gas law. So for example, if a balloon at STP, remember that STP is standard temperature and pressure, has a volume of 5.78 liters, what volume will it have at a temperature of -10 degrees Celsius and 0.38 atms? Well, we know that it's at standard temperature and pressure. That means that our temperature, our T1, is 273 Kelvin. Our P1, because it's at standard pressure as well, is 1.0 atms. And it says it has a volume of 5.78 liters. So V1 is equal to 5.78 liters. What volume will it have at a temperature? Okay, so we have a second temperature here of -10 degrees Celsius. We add 273 to that, and we should get 263 Kelvin. Our pressure, our second pressure, is 0.38 atms. And it asks us for our second volume. So we're going to be using the combined gas law. We know that because we have two temperatures, two pressures, and two volumes. So we have all three variables, which means we need to use the combined gas law. So we're going to use P1 V1 over T1 equals P2 V2 over T2. Now, unlike before, you do not have to make a prediction because sometimes these things contradict each other, so we're not going to make a prediction this time. We're just going to plug things in and solve for what we're looking for. So we have our first pressure, which is 1.0 atms, times our volume, which is 5.78 liters, divided by our temperature, which is 273 Kelvin, is equal to our second pressure, which we know is 0.38 atms, times our second volume, and we don't know what that is, so we leave it as V2, or you can put X in there, and our second temperature is 263 Kelvin. Now, to get V2 by itself, we need to multiply by 263 and divide by 0.38. So here we divide by 0.38 ATMs and multiply by 263 Kelvin. So now our 263s cancel out and our 0.38s cancel out. And over here on the left side, our ATMs cancel out, our Kelvins cancel out, and we're going to be left with liters. So we take 263 times 1 times 5.78 divided by 0.38 divided by 273. And when we do that, we should get V2 equals 15 liters. So our answer is 15 liters. Hopefully, after doing all of the gas law problems that you did previously, you'll find the combined gas law to be fairly simple to use, and good luck.